let me tell you about one of my favorite principles from mathematics, called the pigeonhole principle. So it goes like this. Suppose that n is a counting number, so a number like 1, 2, 3, 4, 5, or so on. If n plus 1 pigeons are placed in n pigeonholes, then at least one of the pigeonholes will contain 2 or more pigeons. So in this case, suppose we've got 4 pigeonholes, and we're trying to place 5 pigeons into those holes somehow. We can see that the first 4 could get distributed as far apart as possible by placing 1 pigeon into each hole, but by the time we get to the 5th guy, he's going to have to get paired up with somebody. So in this case, we've got 1 pigeonhole that contains 2 pigeons. A classic application of the pigeonhole principle is birthdays. There are 366 possible birthdays if we're only counting days and months. And here we are including February 29th. So in a room of 367 people, at least 2 will share the same birthday. That comes immediately from the pigeonhole principle. Let's take a look at this cool problem. So it goes like this. Peggy is going to plant parsley in her organic garden. She has allocated a square 8 by 8 inch plot and would like to plant at least 5 sprigs of parsley. It's recommended that any 2 sprigs be at least 6 inches apart from each other. Is it possible for Peggy to plant 5 sprigs in her 8 by 8 plot without overcrowding the herbs? Now, of course, you could do this problem in many other ways, but this is just one application of pigeonhole principles. So let's see how we can set this up using pigeonhole principle. So I start by drawing my square plot here, that's 8 by 8 inches. And here's the trick. I'm going to divide it into 4 equally sized squares. And I'll label these squares S1, S2, S3, and S4. Now, I want 5 sprigs of parsley in here. So I'm going to start by distributing them as far apart as possible. So 1 sprig per square. But you can see now by the pigeonhole principle, at least one of these smaller squares that I've made will have to contain 2 sprigs of parsley. So suppose that is S1. So our first square, S1, will contain 2 sprigs of parsley. Now let's see what happens here geometrically. Let's just focus in on this smaller square now. It is a 4 by 4 inch square. And suppose we try to place the 2 sprigs of parsley as far apart as possible from one another. So clearly, those 2 sprigs would need to be placed at opposite corners from each other to maximize their distance. And now imagine drawing this diagonal line to indicate that distance. Next, we're going to use a classic tool for mathematics, the Pythagorean theorem. Because notice that now we've got a right angled triangle here with 2 side lengths A and B, each equal to 4 inches. So using Pythagorean theorem, we know a squared plus b squared is equal to c squared. We can solve for a missing side c, which is precisely our diagonal, or the distance between the 2 sprigs. So doing some algebra, we find that c is approximately 5.7 inches. So this means that by the pigeonhole principle, at least 2 of the sprigs will be within 5.7 inches of each other. So is it possible to plant 5 sprigs of parsley in an 8 by 8 inch plot so that any 2 sprigs are at least 6 inches apart from each other? The answer is no, it's not. So in this case, either Peggy has to plant fewer sprigs or she's got to be okay with some overcrowding.